We are looking at the Honors Math 2 Chapter 8 or Unit 8 review dealing with circles. So we start with our first question. EF and EG are tangents to the circle. We need to find the measure of angle E. So angle E is right here. Now we know since they're tangents that the tangent and the radius form a right angle whenever they intersect. And what this becomes, it becomes a quadrilateral, which we can draw on the outside. It's a specific quadrilateral. It's a kite that we have. And we can use the fact that we know these angles add to 180. They are supplementary here, which helps us solve it. It would be, if you add them all to 360, it would be what's left also. So in either case, we're going to get 30 degrees here, and our answer is 30. What you can also do, and I've seen some students do, is they want to cut this in half and bisect it. And when you do that, this 150 becomes 75, 75, which becomes 15, 15, and also adds to 30. Next problem, we have a tangent, so we're going to put a right angle there. HJ is tangent to circle P, find the value of x. Whenever we see tangent in a problem like this, it's going to be a Pythagorean theorem type problem to find the value of x. Our hypotenuse is opposite the right angle, so that's 7 plus 18, or 25, equals 7 squared plus x squared. We get 625 equals 49 plus x squared, which becomes 576 equals x squared. Take the square root of both sides and we get 24. For the next problem, you need to find arc BCD. C should be right there, and that is this arc going around. So a couple key things that we notice. This is the center, and that makes this a diameter. So that's going to cut the circle in half, and so we have 180 degrees on this side, 180 on that side. We don't know if these two arcs are necessarily the same, and that's fine, but we're going to use that information to help us. So if I have 34, the arc there is also 34. Then I can do 180 minus 34 and get 146 for the arc BC. Now, BCD is BCD. It's going to be 146 and 144, which comes out to be 290 degrees. For the next one, we need to find arc LN, which is the arc out here. We're going to start with an inscribed angle N, which is 28 degrees. To get arc ML, we double the 28, so that's 56 degrees. Now we also have these congruence markings, and those are going to help us because that tells us that MN and LN are the same measure. So I have 360 is the total distance, total degrees around the circle. If I subtract 56 from that, I get 304. Now that's the total for the whole thing that's left, but I know both parts are equal, so I can do 304 divided by 2 and get 152 degrees. For number 5, what's going to help us here is this is an inscribed quadrilateral. In an inscribed quadrilateral, the opposite angles are supplementary. So if this is 80, this would be 100 because they add to 180. And that comes from the fact they open up to inscribed angles, and they're going to be 360, take half of the 360 to get to 180, and it's a rule that helps us. But what it really gets to is the 80 doesn't affect the 2x and the 4x. We're going to say that 2x plus 4x equals 180. So 6x equals 180, x equals 30 degrees, which is our answer. If we went back and checked, you'd get 60 and 120, and those are also supplementary. For number 6, we need to find the value of x, which looks odd because it's kind of like broken off from over here, but x is the radius. So I'm going to draw the radius right here. Now I have a right triangle with 8x, and this is 15. So x squared equals 8 squared plus 15 squared by Pythagorean theorem. We get x squared equals 64 plus 225. 64 plus 225 gives us 289. And the square root of 289 is 17. Number 7, we have PLM is 42 degrees. PLM right here, 42. We need to find M and L, which is the angle here. Now, a few things we know in this first triangle. I have radii here, so that is a isosceles triangle at P, M, and L. So these are both 42. We can also then add 42 plus 42, subtract it from 180, and it tells us that this angle at P, the central angle, is 96 degrees. Now a central angle is equal to its arc, so arc LM is also 96 degrees. And last, what I can do is I'm looking at this angle, which is inscribed, the measure of angle MNL is 96 divided by 2, or 48 degrees. For number 8, we have WY as a tangent. We know TWY, angle TWY is 74 degrees. We need arc WPT. Two ways to find this. I'm going to take 74, I can multiply it by 2 and get 148 for the arc, that is arc TW. And so we'll go 360 minus 148 gives us 212 degrees, which would be our answer here. What you could also do is if I took 74, I know this is supplementary here at point W, so 180 minus 74 would give me 106, and then doubling that would also take me to 212. So two ways we can get to an answer of 212. For number 9, we have an angle on the outside, and that is going to work. The angle is equal to the big arc minus the little arc divided by 2. I know the big arc is 152. I need to find the little arc. And the fact I know the rest of these, I can add them together, subtract from 360, and find what's left over. So I got 152 plus 74 plus 80 gives me 306. Subtracting that from 360, I'm left with 54 degrees right here. So we put 54 in the equation. Now 80 and 74 are used to get to this angle, but they're not actually in the formula. So now we're going to do 152 minus 54 is 98 divided by 2, and we get x is 49 degrees. Number 10, we need to find the value of x in the circle. What we're actually going to do first is going to find y, because this lines up with the angle on the inside of the circle. So we're going to say y equals 196 plus 92 over 2. So I add those together, I get 144 degrees. Now that is these two angles. Angle x is the supplement to that. So x is equal to 180 minus 144. So that would be 36 degrees. For our next one, we need to find the length of MA. Let's put an x right there. This is going to be segments on the outside of the circle, and you're always going to multiply the secant times the external portion. So let's look at that. So on the top line, the secant is the whole thing. That's 14 times the outside, which is 6. That's equal to the whole thing on the bottom line, which is x plus 7, not 7x, but x plus 7, times the outside of 7. Now we multiply here. 14 times 6 equals 84, equals 7x plus 49. I'm now going to do 84 minus 49, get 35 equals 7x, and x equals 5. So we put a 5 right there. Next problem, we got to find CD, and that is the diameter within this, but it's very much so related to this problem, but what's different is now when you start with a tangent. When you start with a tangent, it's tangent squared equals the same relationship we had in the last problem, the whole thing, x plus 6, times the exterior. So we get 144 equals 6x plus 36. We subtract, we get 108 equals 6x. We're going to do 108 divided by 6, which is 18. Number 13, we have UP is 2 and P is 4. UW is 18. we need to find LP. Now if 18 and this is 2, I'm going to put a 16 right there because that's just segment addition. And I'm looking for LP, so we'll put an X because we want to think of that. This is segments inside the circle, so we multiply the segments that form the same chord. So we're going to go 2 times 16 equals 4 times LP. Comes 32 equals 4 times LP. We divide by 4, LP equals 8. For our next problem, we have we need to find angle PAM. Now, there is a quick rule to how to find this. Let's go the other way first and see what happens, see what we get. So 156 is the opening to this arc for angle P. We take half of 156, and that's 78 degrees. Now this also is a diameter, so I could do 180 minus 156 here, and I get 24 degrees. Taking half of that, we get 12. Now 78 and 12 are the other two angles in the triangle. Those add to 90, so this must be 90 degrees. That's the long way. The faster way to it is this angle PAM opens to half the circle. It's a semicircle because it's part of the diameter, so we know it's half of 180 and it's going to be 90 degrees. A little bit easier way to get to it. Next we have angle AGH, which is this angle right here, which is deceiving because it uses A, but it's actually the part that opens to K and H. So if I knew this arc, I would know I could find the angle I want, which I kind of do because 52 opens to this arc. So if I doubled 52, I get 104. Now to get back to the inscribed, I take half of 104 and I get 52 degrees. Another rule that helps you here is that inscribed angles that open to the same arc are congruent, so we could have seen that this is 52 and we could have set them equal. Moving on, next one we have BC and AC are tangents. We just know they intersect the circle at one point. We're not going to draw radii in. We need to find arc BDA. So let's say BDA is X. Well, the rest of the circle, because there's no empty spaces not included, is 360 minus X. Because whatever that, let's say this is 200. Well, we do 360 minus 200 to find that. So we can write that expression as that as well. So what we're going to look at here is 43 degrees is equal to the big arc, X, minus the little arc over 2. Now we're going to use a little bit of algebra skills here to solve. So I could multiply both sides by 2, and I get 86 equals X minus 360. X minus 360 minus X. Let's distribute out the negative, and that's going to become X minus 360 plus X, which is 86 equals 2X minus 360. We're going to add 360 to 86, and we get 446 equals 2x, and dividing that by 2 we get 223. So the measure of that angle, the measure of that arc, is 223 degrees. Another way you could have found it, which may have been an other option, I did mention they were tangents. So off a similar problem we did earlier, I know these two are supplementary. So 180 minus 43 gives me 137. Which is this angle, which is the same as the arc, which I could then subtract from 360 and get to 223 also. It's a bit of a jump. This is a little better process to get through. For number 20, we need to find the measure of arc TR. So the arc here. Now, I know that's 110. Let's try it again. We need to find arc TS. Now, if this is 110, and these are both congruent chords, I know that this is also 110. 110 and 110 is 220. 360 minus 220 is 140 degrees, and that would be the measure of arc TS. For number 21, we know GMJ is 220 degrees. We need to find GK and JM. Now, we can actually get a lot of work here because notice how we have a chord bisected a chord perpendicular to a diameter. That tells us it splits the circle in half, so it's congruent on either side of this. So 220 divides up to be 110 and 110. So that itself gives us that JM is 110. Now, since this is a diameter, I also know that the left side is supplementary, so 110 and GK have to add to 180, so we're going to get 70 degrees right there. This would also be 70 degrees. Number 22, we have segments on the inside of the circle. So we're going to do 5 times x plus 10 equals x times x. This gives us 5x plus 50 equals x squared. In moving it all to the other one side, I get x squared minus 5x minus 50 equals 0. From this point, we need to factor. So we're looking at what multiplies to negative 50 that adds to negative 5. Our factors of 50 are 1 and 50, 2 and 25, 5 and 10. Now, one of them has to be negative, because I want a negative 50, and I want them to have a sum of negative 5, really meaning they're 5 apart. So let's look at these two. If I had 5 and 10, and I made one of them negative, it would make it negative 50. Which one needs to be negative so they add to negative 5? Well, if one of them is negative, I want the bigger one to be negative. So let's think if it was negative 10 and 5, that would work. So our factors are x plus 5 and x minus 10. Now, this is not our answer because we then need to set them both equal to 0. That's called our zero product property. And we get that x equals negative 5 and x equals 10. Which at first looks like two solutions, but we couldn't have lengths of negative 5, so that's out, and our answer is 10. We could go back and check. If I put 10 and 10 here, this would become 20. 10 times 10 is 100. 5 times 20 is 100. We have a value that works. Last one here, we have common tangents that form a quadrilateral outside the circle. So we have AB is 12. CD is 13, we need the perimeter. Now they gave us 4 and 6 here, and these are actually going to help us, because if this is 4, so is that tangent, because they meet an external point. If this is 6, this part is also 6, which if we know this is 6, C to that tangent, we know 7 more to get from the tangent to D, which also gives us a 7 there. Now, these were 4s. If this is 4, I have to have 8 here, because that adds to 12, which also brings 8 to this segment. So now when I go through my sides, I have 15, 12, 13, and 10. So I'm just going to add those all together, and it looks like I get a perimeter of 50 units.